Welcome to tomorrow's Tech Today, a Scaling AI Everywhere special. This podcast episode is sponsored by Intel. And to find out more about Intel, please click on the link in the description to learn more. Hi everyone, and a very warm welcome to tomorrow's Tech Today, bringing you the latest in technology, talent, and transformational change. With me, your host, Professor Sally Eaves, Chair of Global Cyber Trust at the Global Foundation for Cyber Studies and CEO of the non-profit Aspirational Futures. Today's episode really encapsulates the vision to scale AI everywhere for business and societal benefit too. And coming live right from the heart of the Intel Innovation event as well. What fantastic timing. And to dive into all the details and what's to come next, I could not think of a better guest to speak with. It's my pleasure to welcome Wei Li, Vice President and General Manager of Artificial Intelligence and Analytics at the Intel Corporation. Welcome, Wei.
Thank you, Sally. I'm so glad to be here.
Oh, thank you so much. Really looking forward to our conversation today. And kind of following on from my brief introduction there, I'd love to hear a little bit more about you, the person behind the technology. I'd love if you could share a little bit more about the work that you're doing at Intel and how you got there, how you got to that role. I really think it could inspire a lot of people.
Yes, definitely. So I'm very fortunate to lead AI and analytics at Intel. And I have a group of magicians, and I would like to tell people we do magic. So magic means go for goals that seems impossible, and our magicians will make it happen. Actually, and the magic means in the past few years we have reduced the AI inference latency from seconds to milliseconds, and the AI training time from days to hours. And magic means we're making AI accessible by anyone, and we're enabling AI everywhere. So you asked about myself. For me personally, I always like innovation and staying at the cutting edge of the technological changes. And it is great to be a computer technologist today. So when I was a graduate student many years ago, I worked on supercomputers. And today we work on making computers run fast for AI problems. As you know, AI problems tend to be very computational intensive. So it's a tough, challenging technical problem to solve, but we all like tough problems to solve, right? And so AI is successful today. One big reason for AI success is because the computers are getting so fast, and we can process large amount of data. So it is truly exciting. I just want to add one more thing here. I just came back from Dubai. I was in Dubai last week, where I give a invited talk at a big tech show called GITEX. It's one of the largest tech shows in the world, and it was so great to see real physical people, instead of virtual people, right? And that they were demonstrating the latest technologies. And on top of this, Dubai, is a amazing city. I mean, I just find out that was my first trip to Dubai. It was at 20 years ago. It was still a desert, and today it has world's tallest building. Burj Khalifa, the tallest building, and endless skyscrapers, right? So when I think about AI, AI today is already more than a desert, right? And AI tomorrow will be really anything we can imagine. So it's really up to us to create AI everywhere here.
I love that. What a great example. And I was kind of down the road from you in many respects. I was in Abu Dhabi for the World Policy Conference, and I heard about your session all about AI for good and scalability. So I love that. So very, very kind of shared thinking on that one, I think. And what a great analogy about where you can come, that 20-year example with Dubai's innovation, but also that art of magic. I love that. I'm going to use that example. I think it's fantastic. And encourage
Yeah.
people into the sector as well, showing what you can achieve, what you can build with technology. I think it's a great example of the dynamism of the space and what you can achieve. That's fantastic.
Yeah. It's just so amazing. Yeah.
Brilliant, brilliant. And kind of drilling in a little bit into the agenda of everything that's been happening at the Intel Innovation event. One of the standout sessions for me was the one, The Fast Path to Scale AI Everywhere. And really, for me, what came to the fore was how to clear that path for AI. So there's four central pillars that have been spoken about. So scalability, productivity, performance, and also innovation. I'd love it if we could kind of walk through those in turn. I think they're so important. And maybe we can look at how Intel is addressing those challenges. So maybe starting with the scalability one.
Yeah, that's as you mentioned. These are the four pillars for AI at Intel, and on the scalability side, scalability has many different aspects to this, right? So let me just mention one thing. So we talk about AI everywhere, and Intel really is in the best position to achieve the goal of AI everywhere, and that's because Intel. If you think about Intel, Intel Silicon is everywhere today already, right? So when you have a data center, you have most likely Intel inside, right? So when you have a cloud, most likely you have Intel inside. And if you have, I have a laptop here, most likely, actually it is, I know my laptop has Intel inside, right? So if we can make Intel Silicon smart, and plus we have all the smart software on top of this, we can really get AI everywhere, AI for everyone to use here. And today we can, quite often we run AI in the data center and the cloud. But today we actually announced during the Intel On session, just a few minutes before this, um, we announced a data science PC. So with data science PC, you can process large amount of data already, because even on the PC side, the amount of compute is also increasing, and the amount of memory, particularly with persistent memory. So you can handle a lot of data over there already. Intel is well positioned to get to AI everywhere. And I just want to give you one example here. So when we talk about scalability, and the other aspect of scalability is you can process a large amount of data. So one example actually was also mentioned at the Intel On is, my team worked with a MasterCard. And I'm sure you all heard about MasterCard. You probably carry one of the MasterCards as well, right? So they created new AI services for their card issuers. So they can serve, the card issuers can serve their customer base, which is actually 1.6 billion, global card holders, right? So when I think about the number 1.6 billion people, I lost track of what is the world population, right? It's only in the billions, right? So you're covering a pretty large number of people here, and the way to train their models, they actually are able to include multiple deep learning models inside these AI services. And the way to train this is they manage to leverage, use hundreds of billions of records, right? So in the past we think about millions, these are already big numbers, but we're talking about billions. We're talking about hundreds of billions of these records. So really it is getting bigger and bigger. And then the last thing I want to mention in terms of scalability is AI is evolving. When the 6, 7 years ago, when we started on AI side, the breakthrough for deep learning was finally AI was able to recognize cats and dogs, much better than humans. That was a breakthrough, right? And so it started on the computer vision side. But over the past few years, you have seen a lot of variety of AI usages, and come all the way from computer vision to natural language processing. I mean, you can talk to AI nowadays, right? And actually, I was in the conference, about a year or two ago. At that time, it was still live before the pandemic. During the conference, they had simultaneous translation, right? Real time translation, and it was a pretty decent. And then nowadays, wherever you go, you do on internet, you get a lot of recommendations, right? So these are the recommendation engines behind all these things, and just everywhere. It's pervasive. And I also got a chance to talk to work with some startups, and they're working on graph analytics for drug discovery. I mean, using graph neural networks for drug discovery. So there's all kinds of things going on. So in terms of scalability, it's going to be everywhere people can use it. It's going to be large amount of data people can process, and it's going to be all kind of AI applications you can do, simply because we have evolved in the past couple of years. And Intel, as a a scale company, right? I mean, we are a big company, and we can really do all of these things. I mean, that's the advantage of inside a big company versus small startup. You can really do big things, right?
Absolutely. It's that making that magic happen, isn't it? And I love the way as well, you kind of talk about that leadership position there and that ability to do more. I love the fact that I think Intel's really using that sphere of influence in a very positive way. I mean, you mentioned examples there around for business, with MasterCard, but equally supporting a lot of social impact endeavours as well. Things like the
Yeah, yeah.
HPC Consortium for Healthcare, all sorts of different examples there. So it's right across the spectrum of impact. So that's the scalability made real, isn't it, for shared value benefits?
Yeah, yeah.
Fantastic. So I'd love to dive into these other three pillars that we were talking about as well. So perhaps next on the list, we could look at the role of productivity and that critical role in scaling AI everywhere.
Yeah, so productivity is super important because we are in the Intel on when our CEO Pat talk about developer first, right? So we want to make sure developers are happy. I mean, developer can develop whatever they want to do, easily on our platform. And when I think about productivity, the different aspects to this as well. So one is if we want to have people develop things on Intel platforms easily, so they don't have to rewrite their code, they restructure their things and all that stuff, right? So part of this is we want to embrace the broad software ecosystem, right? Intel is big, but we have a big software ecosystem running on top of Intel. So we have the popular AI frameworks running on Intel already. For example, TensorFlow is probably the number one most popular framework for deep learning, right? PyTorch, MXNet, all these things you can name from the deep learning side. And beyond deep learning, there also the classical machine learning like scikit-learn or XGBoost, and these are all very popular. When we talk about downloads, it's a huge number in terms of downloads, right? And all the way to data analytics, we have a Spark, Modern, all these things. So part of what we do today is we want to make sure all these things run well on Intel platform, and people can just use it seamlessly, right? Because you may be using TensorFlow already. Now, if you want to run TensorFlow on Intel, you use the same TensorFlow. Nothing, you don't change anything, right? So that's part of the productivity is to seamless, right? And then the other part is we want to do more than that, right? We want to do more than because there are new things happening for AI, and there's new tools we are developing to do these things here. So one example here is our hardware has added new features. For example, traditionally on deep learning, you use something like 32-bit. You use 32-bit to do computation, and Intel added integer 8, the 8-bit computation inside the processor, right? And you can imagine between 32-bit and in 8-bit, the 8-bit version will be much faster, right? Because in the 4 times smaller, right? So if you can make that happen, it will be great, right? Now, traditionally, the way conventional way of doing this is it takes quite a bit of manual effort to convert a model in 32-bit to 8-bit, right? So it can be done, but it's just quite a bit of work. People have to think in terms of mathematically, how do you represent the 32-bit computation using 8-bit, and how do you make sure once you have changed the model, your model is still accurate, right? Because you don't want to make something run fast and it's wrong, right? That's not good. Okay, so you want to within a certain accuracy. So that process, it was not a trivial process. So that's what we did. We created a new tool. It's called Intel Neural Compressor. So with that tool, we actually automate the process to try things automatically, to do data, to do calibration automatically. So from user perspective, you don't have to write code anymore. You don't have to write a lot of code. All you need is working with a GUI, and you click on the GUI, and then within minutes, these things are done. right? So this is pretty amazing, and we have a lot of people adopting, getting it's a new tool is getting adopted quite a bit already from the big CSPs, cloud service providers, from the end customers, like the research institution like CERN. You're based in Europe, right? CERN is a so well-known research institution, and they do high energy physics. I'm only a computer scientist. I don't know I don't know much about physics, but it's all the fancy stuff they're doing in simulation and all these things, and they want to use AI to speed up simulation. So with a tool like this, it can help them speed things up, and the productivity gain we get out of these tools, out of the Intel neural compressor, is more than 10x. Right, it's more than 10x productivity gain, and at the same time you're getting performance out of it. So these are the variety of things we're doing here for the productivity side. Both in terms of making sure that the current ecosystem software is doing well, and we're adding new tools to improve productivity that way.
I love that. I also love the fact those tools are kind of democratizing access in many ways to be able to redefine the capabilities you need as well, like the GUI you mentioned and things like that as well. So I love that particular aspect of that as well. Fantastic examples right across the board there, Wei. Thank you very much. And perhaps we can move on now to look at performance. I was literally just seeing a world record being broken, actually, right at the heart of the Intel Innovation event, which is fantastic, all around overclocking. So that's one example of performance. But I'd love to kind of explore that around its role in terms of the scaling of AI too.
Yeah, so performance is the foundation for all of us, right? It's foundation, and we are a company. We deliver all the computer platforms, right? And the way we compete, it's a race. It's arm race today, which is who gets the better performance and who can deliver the performance in the pervasive fashion where everybody can benefit from this, right? And in particular on the AI side, as I mentioned earlier, AI is very computationally intensive, right? It takes a lot of flops to do things, and people talking about petaflop, exaflop, and all these big numbers you threw out there, 10 to the whatever big number over there, right? So these things, the problems are getting bigger and bigger. Models are getting bigger and bigger. And one example I've been using for a while is within natural language processing, that the model size in terms of number of parameter used to be, 5 years ago, used to be less than 100 million, right? I mean, even 100 million is not a small number, but over time, got improved, got changed to billions, and now it's getting to be trillion, right? So these are all very not large numbers here, and then as a result, as an industry, we all try to accelerate, right, in different ways. So we do both hardware and software, and this is on the hardware side, there's a lot of companies trying to do hardware acceleration, and from the big companies like us all the way to startups, right? So many startups doing this stuff as well. So when I think about hardware acceleration, there's really sort of three different categories, right? So there's one category, I would say CPU, general purpose CPU with hardware acceleration for AI, and then the second category is GPU. With a lot of compute for AI, and then the last category is the dedicated purpose-built accelerators for AI only, right? They cannot run other applications, but they can run AI, the convolution very fast and all these things. Right? And Intel is investing in all three of them, right? Because we don't really know. I mean, there are trade-offs. In some cases, one is better than the others. There's no clear winner today. If somebody can say, "Oh, all I need to do is this," right? Because so again, there's we are a big company. We can actually afford to do all three of them, and we are doing all three of them here. So in on top of this. Uh, Actually, let me talk about on the CPU side. We have added new instructions, and for integer 8, I already mentioned. And then our next generation, Sapphire Rapids, we add something called AMX, which actually does matrix computation. So imagine doing matrix computation inside the hardware directly. And then we also have the GPU side. On GPU side, a couple of months ago, we had the Intel Architecture Day, and our team worked on this, and we actually demonstrate very good performance, on the pre-production hardware for GPU. And then on the purpose-built accelerator, there was a great news also. So Habana Intel acquired a couple of years ago. So it was yesterday, right? It was announcement came out yesterday. They became live on Amazon, right? People can actually use it on Amazon. So we are making progress in all three fronts from the hardware perspective. Now the other thing I want to mention here is actually software, right? Because hardware alone is not sufficient, right? Because um, when I the way I want to think about this is, particularly during pandemic, one of the benefits of pandemic is I actually got to pick up biking. So I got a chance because I work from home, and during lunchtime I just go out, do half hour quick biking. Actually, I live next to Stanford, so it's going around Stanford is was beautiful to do biking over there, right? So when I think about biking, people have a different kind of bikes, right? They have road bikes, faster bike than the bike you use for city travel, right? But bike alone is not sufficient. You need learn the hard way. Actually, you need a better bike, not only better bike but also better biker as well to compete, right? And so in the same fashion, the hardware acceleration for AI is necessary, but it's not sufficient. You need the software on top of this. So a couple of weeks ago, I wrote an article on VentureBeat. I introduced the notion of software AI accelerator, right? And I think about this is it like a biker, software AI accelerator, and they will optimize the software on top of the hard accelerated hardware, and you can get huge performance gains, right? So imagine a biker can improve performance by 10x, right? So if you improve by 10x, if I can improve my biking by 10x, I can win Tour de France very very easily, right? And if I can improve my biking by 100x, then I can be flying as a supersonic jet, right? So it is huge difference, and that's what we're getting on software today. So software can improve performance by 10x, by 100x. So these are all sort of huge numbers we can do on the software side. So performance is very important, and we've been improving performance in these different libraries that I mentioned earlier, right? So one example here is Amazon. So Amazon has a project called Auto Gruon, which is doing auto ML, right? So you try to automatically pick the right ML algorithms and all that stuff, and so they picked one of the slowest algorithm from the set of algorithms they're doing auto ML on, and they use our library, so use our Intel extension for scikit-learn. So they turn the slowest algorithm into the fastest algorithm, right? Simply because they use the optimized library, scikit-learn library we have here, and these things will have a direct impact on the quality of these models, because when you do auto machine learning, when you do things fast, you can pick the right algorithm, and you can increase your accuracy also. So there's a lot of implication in terms of better performance all the way to better quality of your machine models.
Fantastic. I love that. And thank you for bringing both perspectives to the fore there, across hardware, but the software play you mentioned there, equally as important as well. So I think that's fascinating. And I love your example about the biking as well. I hope I can I'm kind of trying to do a charity Everest climb next year. So maybe I can take some of that performance increase into my journey towards doing that as well. That would be much helpful. Thank you. That's brilliant. And it kind of leads us on to that fourth pillar of some of the news we've been discussing so far, and that's the role of innovation. So I'd love to just drill into that final piece in terms of that enablement, really, of innovation to advancing AI as well.
Yeah, so AI is all about innovation, right? So as I mentioned, I've been doing innovation all my career. That's a fun part of the job is you can work on new stuff, you can work on the cutting edge stuff, right? So the one thing I already mentioned, the Intel Neural compressor is one of the innovative projects we created. People and my team looked at this. They say, hey, why do we do something new here? So that was that's a new project. And the other thing I want to mention here is the AI continue to evolve, right? There's many different opportunities, and one of the things I care about a lot is applying AI in healthcare, right? So once you have in the domain of healthcare, data privacy is very important, and the security is very important, and all these things. So part of what Intel has done. So we have Intel Labs. They all continue to push the boundaries of AI also. So they have created something for federal learning. As you know, data privacy important, and federal learning is a new approach to move your modeling activity closer to data, instead of moving your data to models, right? So Intel developed this OpenFL, which stands for Open Federal Learning. That is a Python open source framework for federal learning, and that's very interesting. We're facilitating the advancement of federal learning there. And then, in addition to software side, Intel also has hardware features for security, right? And you may have heard about the SGX, software guard extensions, and that give you the capability for running a piece of code and data inside secure enclaves, right? When you're inside secure enclaves, the data and the code are protected. Nobody can, no, it's building inside hardware, so software cannot get into it, right? So that's the advantage of doing both software and hardware together, to get to preserve privacy and the security here. So that's just an example of the innovation, and there was a lot of other stuff going on, and there's no shortage of opportunities to do innovation inside AI here.
Absolutely. It's almost like a pick and mix. It's hard to know which one to pick, I think, in terms of the
Yeah,
innovation
yeah,
we've seen. Absolutely. I totally understand that. And
yeah.
also, the culture that supports that innovation as well, the opportunities for skill development and outreach as well. I've been super impressed by those examples too. So all of those things coming together, it's always that combination, isn't it, with technology, process, culture, shared values and skills all coming together as one. So fantastic. I love those examples. Thank you. Well, that's brilliant. And another thing that I noticed from a couple of the guest kind of sessions that we saw as well, where some collaborators were brought into discussions. I love that. And there was quite a lot of discussion around AI workflow and the key stages that were involved in that. And I'd love your take, just reflecting on that a little bit more about model centric and data centric approaches to AI. What's your thoughts on that?
Yeah, so that's a very interesting topic, because when you hear in the news, people tend to talk about model, right? Because that's sort of the exciting part. We have deep learning, we have this neural network going on, and all these things. But when I talk to customers, talk to people who actually developing these things, and it is a end-to-end process, right? Because people have data. They have you have the Mastercard case. We have 100 billions of records and so on. So people have a lot of data, and then they just want to get model developed and deployed in applications, right? And so really it is starting from data, right? So it's actually end-to-end process from data all the way to deployment, and that's very different from thinking about modeling alone. And so today, majority of data is actually on Intel servers, right? Because we've been in the server business for a long time. So most of our stuff is data is actually on Intel server. And on the application side, major pretty much every application can run on Intel CPU, right? Because it is the nature of the general purpose system we have here. So we have all the applications with all the data, and then we are developing a lot of capabilities for modeling part as well. So we cover end to end from one to the other. Now on the software side, we're doing two things here. So one is we want to make sure every stage of the pipeline you have the optimized software, libraries to support all of these, right? Because when people, I mentioned, data analytics, machine learning, deep learning, and so on, and we have TensorFlow, PyTorch, Modin, Spark, all these. So we're optimizing all of these things here. Right? So for each component, we want to make sure they are well optimized, and particularly for our platforms. When people run the end-to-end pipeline, individually, component-wise, it's all doing well on our platform. Now, on top of this, we're also, talking about innovation, right? So we're also creating new tools to tie all these things together. So we have the Mastercard case we talk about. We have a tool called BigDL. Actually, it used to be called Analytics Zoo. So sometimes you may hear both names, Analytics Zoo and BigDL, and it's an open source project also. So that particular tool allows the user to work in the same environment. For end to end, you start from data, model, deployment, you stay with the same environment, and that makes the development much easier, and also make the data movement much easier. So you don't have to copy your data to another place and do modeling and then copy the stuff back and do deployment, right? You don't have to break the pipeline. You actually have a seamless pipeline doing all that stuff, and that has been used by many users. So we talk about in Mastercard, we talk about Burger King, we talk about other companies like SK Telecom in South Korea, right? So there are many people doing these things, and we continue to move up the software stack to make it to do the end to end much more easily and in a much productive fashion. So tied to the productivity we just talked about earlier, right? Make it easy. So we're adding multiple features, sort of domain specific features to this as well. So one of the features, we talk about security. So PPML, so privacy preserving machine learning, right? So we're adding that in that tool as well. So when people try to get security, you just interact with our tool and go from there. And we're adding other things like special APIs for time series, right? So time series as a AI domain is getting more and more used, right? So a lot of the application turned out to be time series problems, right? So the networking example I mentioned earlier, SK Telecom is a time series problem. And if you care about Wall Street, right? If you talk about financial trading, all these, a lot of the data is all time series data, right? So a lot of things you can do in a more easier way inside toolkit like this to do a end-to-end solution here.
Fantastic. Such a range of examples there. That's brilliant. I love that kind of embedding, that layering of different functionality and features and making it more seamless, as you were saying there. But the embedding of security, for example, I could go on and on. That's fantastic. Such a range. That's brilliant. I love that. And it kind of brings to the fore as well. You mentioned collaboration a little bit there as well, because we've got this combination, tech innovation we've been talking about, fantastic examples of that, but also the power of partnership to make things happen as well. So I'd love to hear a little bit more around that side of everything that Intel's doing in terms of the AI partnerships you've fostered and collaborations within the broader community as well.
Yeah. So one of the key goals for Intel is open, right? So we do a lot of things in open source, and pretty much everything I mentioned so far is all open source projects. So we created Analytics Zoo, BigDL, it's an open source project. We created the Intel Neural processor, it's a open source project, and another project, is OpenVINO, which is a customized inference engine for on Intel platforms, and that's also open source projects. So there's a lot of open source projects going on here, and we work with many different partners, right? So quite often we contribute to the open source community, and for example, we talk about TensorFlow, right? Google created such a successful framework, TensorFlow, which has a huge number of downloads every year, and so on. So what we've been doing here is when we make these changes, and we actually upstream, contribute to the mainline TensorFlow repository, right? And then in addition, we also work with Google closely to improve TensorFlow in general, right? And this was mentioned in the Intel On as well. So TensorFlow is evolving as well. TensorFlow wanted to be able to support multiple accelerators, right? Different kind of accelerator in some kind of union, some kind of modular fashion, right? And Intel is one of these architects in my team. He made a proposal, a few proposals to Google, and together between him and Google, eventually they co-architect the what they call pluggable device mechanism, right? And with the mechanism, you can actually seamlessly support multiple AI hardware accelerators, and without any change to the TensorFlow code. So that's amazing. I mean, that enables TensorFlow to support and so the many different new devices. So we benefit from this as well because we do our accelerators like a GPU, right? So we are building, actually my team works on both CPU and GPU side. So on the GPU side, we are using that mechanism to support our GPU, and not only Intel but also the entire industry. The other companies have adopted this particular mechanism to support their accelerator as well. So we are doing both. We are contributing to it, which are optimized for our platform, but also making contribution which will be good for the overall ecosystem, right? So that's on the TensorFlow side. Now the other example I want to give here is Python. Python ecosystem. As you can imagine, Python is the language, right, for data science and for AI, and all the things people have created. These are all actually within the Python environment. And in the so the good thing about Python environment is being evolving quickly, right? It's being changing quickly. And the downside is when you things change quickly, they sort of fragment it, right? And so that makes it hard for people to leverage all of these innovations together because they're not very coordinated because everyone does their own thing here, right? So Intel actually is one of the founding members to try to create so we actually create a consortium. So create a consortium called Python Data API Consortium, and with that consortium between Intel and a few other companies, we try to design the same APIs so different things can interoperate together, right? So eventually makes it easy for developers to work on these things in the Python environment. So this is another example of how we are participating, and not only participating, and sometimes we take a leadership position to push the change in the industry.
Fantastic. I love that. And I love the shared value aspect of that as well, in terms of that giving back to community, advancing things forward. But everyone benefits from that in the ecosystem. I love that. And two great examples there, I think, with TensorFlow and Python. Python's one I use myself a lot with my kind of data science research. So fantastic. That's
Yeah,
brilliant.
yeah, yeah.
And it kind of brings me on to another area, and one that I know we have a great shared interest about, which is really kind of all things tech for good, but in particular how we can harness and apply AI as a force for good. And you mentioned right at the top as well, the keynote you did in Dubai recently that was very much on this subject area as well. And I'd love to kind of share your perspective on that. Again, it's something that's resonated across Intel on, I think, that commitment there. But what would you love to share about some AI for good in action, for example, and the scalability of that, and maybe drawing on healthcare? Because I know that's an area of great interest for you as well.
Yeah. So let me just take as you mentioned, we're involved in a variety of things on the AI for good, and healthcare is a great example because because we all human beings here at the end, we are more common than different, right? And we share the same challenges and all that. And so one of the things Intel has been doing is working with University of Pennsylvania. I want to mention that University of Pennsylvania has a medical school, so they started a federal tumor segmentation initiative, and as part of try to figure out where tumors are and all that, and that initiative is involved many hospitals and healthcare institutions around the world, right? And so it's an international effort, and as you can imagine, when you do it across such boundary, there are a lot of privacy issues and all these things, and that's where it's tied back to the federal learning I talked about earlier. It is a great example of federal learning, and so you want to make sure the physicians in different hospitals around the world can benefit from the better model you created by doing this collaborative effort, because through collaboration you can get a much better quality. So there are paper published to show you can you're doing combining different efforts with different models. You merge these things, and the quality is much better than you do each person doing this individually in their hospitals, right? And so it is a value there, and then it can also ship it to different around the world. People can actually benefit from this. So this is a great example about so on the medical side, there is many different ways of getting AI benefit. As I mentioned earlier, I was working with some startup as well. So on the drug discovery side, there's a it's amazing how much the more I learn about the drug discovery, the more I think AI can help here, because the drug discovery process is not quite efficient, right? And also there are a lot of unknowns. I mean, you're talking about sometimes so side effect for one particular drug, and sometimes maybe you do clinical trial, something, but then there's also the combination of drugs. How much about the side effect coming out of the combination? And there's a lot of unknown over there. So sometimes makes me wonder, a little bit nervous about taking medicines. Like, oh, I don't even know the side effect over there. And again, these are the areas AI can certainly help here.
Absolutely. Yeah, I think that rise of kind of personalized precision medicine will be a great example of that. I couldn't agree more strongly, particularly after
Yeah.
what we've all, experienced over the last 18 months or so. Brilliant examples. That's fantastic. And maybe now we can look ahead a little bit as well. I think it'd be a great place to kind of go to now. It's that time of year as well, isn't it? When people are looking at predictions about what comes next, and you're starting to see them coming out already. We haven't even got to Halloween. But I'd love to kind of take your view on what's next, the advancement of AI, maybe over the next 12 to 36 months. That kind of time frame would be fantastic.
Yeah, it's just so much change. I think it's probably, on one hand, it's the prediction business is a little bit dicey business, particularly when things are changing so fast, right? And the technology, I can expect the technology to continue to change, right? When you look at 3 years ago, we were in certain state. Today it's already very. I mean, I can easily talk about the exascale computation we have. How many flops we have in the machines and all these things. These are all sort of things you can imagine, right? But we'll come back to what our overall goal. Our overall goal is actually we want to get AI everywhere, and AI everywhere, in my mind, is more than technology. Obviously, technology is making things easier for AI to be everywhere. But there's also the people side of it, yeah, which is probably very interesting, because initially AI was only worked on by a very special group of people. I mean, a lot of people with PhDs in AI, who can work on these things, right? And then going forward, in the next few years, I would imagine more and more people can not only benefit using AI, but also can develop AI in some easier way, with the combination of all the things we've been talking about so far, hardware, software, and so on, right? And then probably all the way to like high school students, right? So the way I want to think about this is like, I think in the next few years, AI will be the new calculus. So AI be new calculus. Calculus in the old days was advanced thing, right? You have to go to college to learn calculus. And today, my kids went through high school here, and they learn calculus in high school, right? And so AI will be pervasive, will be taught in many different places, and many people will feel comfortable about AI. It's no longer going to be this niche advanced ivory tower thing. It's going to be everywhere.
I love that. It's kind of that democratization to use, develop, apply AI to create in many different ways. I love that. And you mentioned students there, and you've kind of teed up a little final question for me. So I'd love to draw on an example from a presentation that you gave that I spotted recently. And it was a lovely story. And you were asking students for their aspirations for AI. And one of the answers that came back was doing my homework. I love that. It's so honest. It's kids all over. It's brilliant. I love that. So maybe as our kind of final point of call for today, I wonder if you could share your personal aspiration for AI, for whatever time frame kind of fits you're choosing on that. But I'd just love to hear your final thoughts on where you'd like it to go.
Yeah, so it's great. You actually watched some of my previous presentations also. So thank you for that. I'm glad somebody actually took the time to watch my presentations there. Yeah, so it was an interesting experience with me interacting with the middle school students, right? So they were their dream was for AI to do homework for them, right? So when I look at my life, it was interesting. I spent um, majority of my days in the Zoom or team meetings, right? And so some of these meetings are very interesting, like the conversation we're having today, right here. These are interesting conversation. It's good. We got to see each other on Zoom, and it's actually not. It's a different platform, but we got to see each other on a video conference here. But some other meetings are not that interesting. But I end up forgetting. I have to go to these meetings. Right? So my sort of a very basic hope for AI is maybe AI can someday go to meetings for me, right? It can free me up so I can do something creative, do something interesting, it's human interaction, and think something bigger. And instead of spending all my time in meetings, and it's actually possible. So when this conversation came up if even a few weeks ago, and people say, "Oh, can we demo something?" I don't know if it's doable in next few weeks or not, but maybe longer than a few weeks. Can we design something, right? Can we design something? I guess all we need is an avatar. It's like me talking to somebody in a meeting, and then that person can listen, that the avatar can listen, can actually maybe have some interesting expressions when something fun happens, and then it can actually probably do better than me. It can take notes better than me, right? And it can actually remember all the conversations in the meeting, right? So that, I think that would be cool for me personally. It would be offload me from many of the other meetings.
I love that. I find that handy too. I think that's brilliant. And with all the kind of speech technology developments recently as well, I think it's possible. I think we should patent it quickly. I think I'm with you on that. Absolutely,
Yeah,
let's do
yeah.
it. That's fantastic. Honestly, I could speak to you all day, Wei. Honestly, you've got so much fantastic depth and breadth of knowledge, but also so many wonderful stories that help bring that to life and make it accessible for people at the same time, which I think, technology and education, they go hand in hand as far as I'm concerned. I think it's a great example of that in our conversation today. So thank you so much for taking the time and joining us today and for all your insights about scaling AI everywhere. Thank you, Wei.
So thank you, Sally.
My absolute pleasure. And thank you all for joining us as well. And I'll be sharing more about some of the links, some of the stories, some of the projects we discussed today with some extra links as well, so you can dive in deeper. Thanks so much, everyone, and look forward to joining you on a new episode very soon. Thank you.
Thank you. Bye.
Bye.